And I am here to demonstrate and elaborate more on the Tableau and machine learning aspect of our project. So, what exactly is machine learning? It is essentially the study of creating algorithms that can learn from and make predictions based off of the data being presented. Some of the most common methods would be classification, regression, and segmentation. So basically, we'll start off with explaining classification. And so the classification algorithm is a technique in which that helps to divide the data set into different classes based off of based on given parameters. Basically, this is a supervised learning technique, but we won't need to go much into detail about that since most of the data are that we are going through will be trained by us, hence you know, supervised training. And so basically like an example that I wanted to give earlier with like read of data set of the superstore data set given in Tableau. So, dividing the products based off of how profitable they would become, classifying them like versus profitable versus not profitable, something like maybe even the shipping time, something like that, like fast delivery or regular delivery, whatever the products were sent to the customer as, we can just divide it. We could basically divide it into anything. And so I got the next uh, technique would be regression, and basically that's the correlation between both the dependent and independent variables. So given regression, we like this is a random example also, like predicting the price of a house given the information now. So like you know predicting how much a house will be in X number of years. And so, going back to the Superstore data set again, we can use regression to make predictions with the sales essentially. And so we can predict the sales revenue based on like a variety of attributes, from like we could utilize the product price, dimensions, and shipping cost all to basically predict the sales revenue. And so the last technique that I really wanted to talk to was the segmentation technique. And essentially, that's more of a specific form of classification. It's the technique of splitting the customer base into different groups, and the processes of splitting them is basically dependent on the customer's values and attributes. So it's normally used to group similar entities together. And so basically like customer sales, stuff like that. So segmentation is very similar to it's a form of classification, but just more general. So now that we have gone through a couple of machine learning methods, what exactly are their benefits? Within these three methods, they each do the following. Regression can help identify the most important variables used, and the goal is to typically predict an event that is a numeric value. This in turn allows for more accurate predictions on the data. An example of this would be something like predicting stock prices or even analyzing the risk of investments through previous data. And this would help businesses in decision making for something like whether or not to invest in a certain stock. And so, on the other hand, with classification and segmentation, they both have the benefits of identifying patterns that aren't immediately there. Classification has the benefit of categorizing the data into separate classes and entities, and are also super helpful with decision making. So, something like the medical field, where a doctor can see the difference between an image of a diseased patient or a healthy patient. And then segmentation is very similar to classification, but it goes a little deeper and actually further categorizes the business's customer base by typically dividing it into different demographics. So something like recommending certain products to customers, and it then becomes a crucial part in the marketing strategy. As you can see in the following diagram, there is a specific process for how the foundations of machine learning actually works. We are given a data source that is passed into Tableau itself. Once you are connected to Tableau and connect the instance to TabPy, from there we are able to stay connected with external services like TabPy and run our script so that it is possible to later visualize our data. All TabPy is an external software that allows us to run that Python code. So the resulting script that is being run will be connected, and then it will be easier in the future to visualize and process our data. With some examples using the script functions. So there's the example of the script real, which essentially returns a real number. So each of the script functions, they return their own data type, their own respective data types, and basically the syntax is script underscore data type expression external script. So here, as you can see, we can utilize the connection to TabPy to run this code and create a function called predict stock and see whether or not a certain product will be in stock. We can better train it later with external libraries such as random forest to better train our data. So for example, if we wrote the predict stock function with the script string basically, or like the script bool, it would return true or false depending on whether or not the machine algorithm thinks that it's true or false. Below, there are many benefits to utilizing it with machine learning. Connecting the Tableau Analytics Extension API allows for users to bring scripts from languages such as R and Python, and thereby using their own language models. Tableau can then directly interact with and use these models to allow for users and consumers to also better interact with the visualizations within Tableau. Both Python and R are similar in the sense that they can create calculated fields in Tableau utilizing custom scripts. However, they differ in their primary focus, with R placing a heavier emphasis on statistical analysis. More importantly, both languages provide the capability to connect to specific machine learning models and libraries through said scripts. This can allow for users to use some of the methods previously mentioned, such as classification and regression, to be applied towards the data visualizations. Both Rita and Asane will go further into Python and R respectively and explain how to connect both languages to Tableau and how scripts can be utilized to go through the data and present new visualizations.
How do we integrate Python with Tableau? While Tableau offers the ability to do pretty complex calculations, it no doubt has limitations when compared to Python. And this is where TabPy comes to the picture. TabPy is an API used to connect Python to Tableau. It is an analytics extension from Tableau, which basically enables users to execute Python scripts and save functions using Tableau. So essentially, by using TabPy, you can run Python scripts on the fly and display the results as a visualization on the Tableau. Users can also control data being sent to the TabPy by interacting in their own Tableau worksheets, dashboards, or story using different parameters. So in conclusion, TabPy gives you the functionality of Python with the ease of Tableau. So when you use Tableau, you can define calculated fields in Python. Thereby, you can leverage the power of large number of machine learning libraries straight from your visualization platform. But why exactly do you need TabPy? What problems does it solve, and how does it make our lives easier? As I previously mentioned, TabPy makes it possible to use Python scripts in Tableau calculated fields. So basically what you're doing is you're pairing Python's machine learning capabilities with the power of Tableau's strong data visualization. You can rapidly develop analytics applications that can aid various business tasks. So let me show you what I mean using an example. Now it is an interesting one and is available on Tableau's official website. I'm trying to identify a criminal hotspot or multiple criminal hotspots in a certain city. So here we're going to be using data from city's police department, which consists of calls over 6 years reporting various types of criminal activities. Now, if you look at this data, it is really hard to visualize it and identify patterns by just looking at all of these numbers and boxes. The density of the activity and noise in the GPS reading included makes the job even tougher. but there's something known as a density-based spatial clustering of applications with noise, or in short, DB-scan, which is a well-suited unsupervised machine learning algorithm for this sort of scenario. And the great part is that it is also installed by default as part of TabPy. So this is how it works. It takes in two parameters, one to specify the maximum allowed distance between points for them to be considered a part of the same cluster. So anything beyond these points is not the part of the same cluster. And the second one is to specify the minimum number of nearby points to constitute a cluster. So basically, to be qualified as a cluster, you need a minimum threshold of points. As simple as that, minimum number of points and maximum distance between the points. Once that's done, it allows experimenting with various different values and even frequencies and puts on different labels on different areas. Now, this data can be applied anywhere, from a police department looking for criminal hotspots where they know which areas they should be sending more patrol vehicles to a tourist looking for places to avoid from getting mugged when they are traveling to these particular cities. Or if you are a tenant or looking to buy a house, you know which areas to avoid specifically when finding a place. So this is a great example when embedding a Python code into Tableau worked great for us. Let's move on to the hands-on demo of how we can use TabPy. But before we install TabPy, we need to ensure that we have Python, pip, which is the package manager, and Tableau desktop version on our system. Uh, Here, I'm quickly checking if Python is installed on my system. As you can see, it is. I just exit out of it and then check for the package manager. And as you can see, my system already has package manager installed. So I'll move on to installing my TabPy application. Next, to install TabPy, we'll write the command of pip install TabPy in our terminals and just press enter. And here you will see it's downloading and installing all the required files to integrate TabPy with our Tableau. And we're going to wait for it to complete. Just a few seconds and yep, it's completed. Next, in our terminals, we have to start a server, which will help us integrate Python with the Tableau. We'll simply just write tabpy, and it will ask for our permission to proceed. We'll say why yes, and then if you can see, a server gets connected, where it's saying web service listing on port 9904. We can check this by using this port number and going to a browser and typing in HTTP localhost and giving that port at the end. And this will open up a Tableau web page. Next, we're gonna add our server details to our Tableau software. If we just go to Tableau Desktop, go to Help, Settings and Performance, and Manage Analytics extension. And here it gives us different options of what we want to integrate. We choose the first one because we want to integrate Python. The host name would be localhost, and the port would be the one that was in the terminal, which was 9004. Then before saving our server, we test its connection, and it says it's successful. Then we save our server and we have integrated successfully Python with Tableau. Next, we will check if our Python integration has been successful. So we're going to use a simple example using the database of superstores that comes when you install Tableau. This data source basically shows the different parameters of a superstore, like its location, like the merchandise, their price, their quantity, discount, profit, everything. And if we do a simple visualization of the superstores for each state, let's say we just drag the state to the rows, and then we have to check the profit for each state, I guess he said. So we'll just add it to the marks and change it to text. Here you can see it has different positive, negative values, positive being the profit, and any state that is negative value means it was in loss. And from the left, if we choose color instead of the text, it will give us a range of profit values for each location instead of discrete values. Now, let's say, for instance, we want to be able to visually see whether some state was in profit or loss through some flag that populates in front of our states. To do that, we will go to the data side on the left and create a calculated field. So here we'll just give the name to our field. Since we already have a profit field in our data, we'll give it a different name, let's say profitable. And here is where we write our Python script. So we're going to write a very simple Python script, which will basically check if some value is greater than 0 and add it to our list. We are using here a script keyword of Tableau, and you can see in the drop-down menu there were different options of the data type, but we have to return true or false, so it's Boolean for us. And within the brackets, we are writing our code. We've declared a list, and we're using a simple for loop to check if the value is positive. If it is, just add it to my list. And then at the end, we return the list to our program. Also, we have to check this against some specific value. So here it will be sum of the profit. It's basically grouping all the locations and checking for profit. And here you can see it's also giving me an error if I have it in my code at the bottom, and I fixed it by taking the bracket towards the end. Now that we have written our Python script, we're ready to implement it. So what are we going to do is open a new sheet, and then similar to last time, I'm just going to add my states in the rows, and this time the profitable parameter which we just created using Python script, we add it to our marks and use the color. And here you go, it shows us the flags against each state and whether it's a profit or a loss through two different colors shown on the top right. We're going to change the color. We're going to make blue for true and false as red. And it shows us the same information but in a better visualization, whether it's a profitable state or a loss state. Next, we can take our visualization even further by adding profit to the columns. And this gives us even better visualization in which we can identify which state has the highest profit compared to others. And this is how you can integrate Python with Tableau.
This is Alassane Sarr. Today I'll be presenting how to visualize the data in R. R is a language that is designed for statistical computing, graphical data analysis, and scientific research. It is usually preferred for data visualization as it offers flexibility and minimum required according to its packages. There are some various type of visualization offered by R. The first one is a bar plot. A bar plot, there are two type of bar plot. Is a horizontal one and a vertical one, which represent the data points as horizontal or vertical bars of certain length proportional to the value of the data item. They both are generally used for continuous and categorical variable plotting. The next type of visualization using R is a histogram. A histogram is like a bar chart as it is used bar of varying height to represent data distribution. However, in an histogram, values are grouped into consecutive intervals called beans. In a histogram, continuous values are grouped and displayed in these beans whose size can be varied. The third various way to use R is a box plot. A box plot depicts information like the minimum and maximum data point, the median value, first and third quartile, and interquartile range. The fourth ways of using R is scatter plot. A scatter plot is composed of many points on a Cartesian plane. Each point denotes the value taken by two parameters and help us easily identify the relationship between them. And the last one is a heat map, which is defined as a graphical representation of data using colors to visualize the value of a matrix. And also there is 3D graphs, which is used to create 3D surfaces in perspective view. Uh, and R is like there is a software you call R Studio. So first of all, we need to use R, we need to download that software which is called R Studio. So to download it, this is the link. So when you go to this link, you have two options for Macs, the old one and the new one. So once you click on one link, you will be able to download it. Since I already downloaded, let's open the app. So once we open the software, this is how it's gonna look. We have the left space spot, which is gonna show our file name, and then the right spot, which is gonna show environment, history, connection, tutorial. This is the file if you want to import a CVS file. This is the plot if you want to see the graph. This is the packages. We'll show you how much package they have in the help section and all the and first of all, with R, once you get into it, let me clear. Um, once you get into it, this is you can clear this, and so you have an empty spot. Uh, First of all, we can use a library to start with our graph. So there is different type of library, but usually I use the lattice, which is good for graphs. So once you tap lattice, so now you have the whole page that you can code and using the graph. And to import a file, which is really important, you click on the file and then you go to your desktop. I have a file on this document. If I want to import it, you just put import data set and it will showcase this section. Wait for a couple seconds. Yes, now we are able to import it. We click import. The file will show right here on this section. Yes, this is the file of import. We have 30 rows and 420 columns, and these are the details of what's in the file. And so this section is the view. The view is the view section is what showcase um, the CVS file that we import. So first of all, we can test it and find a mean of value. For example, if I go to where the number is at, okay, so let me use attendance rate. If I put mean, this put the name of the data frame to mean, and sign attendance rate, and if I click enter, it will tells me the mean of this section. You can do it for all the variable. And let's start by importing a graph now. So let's do the let's do the histogram for the histogram section for this is the histogram function. Once you put the histogram, we can put the data frame in it first by putting sign and do use the same attendance rates. Column, we put data equal and x2020. It's right here showing, and once I click enter, attendance rate. Oh yeah, I made a mistake here. Attendance rate should be yes, and as I click enter, it's automatically showing me the histogram that we create. And this is a function. We can use another function named bw plot. So we come here and change it by bw plot, and I'm gonna say click the same. It will change the visual. So first we gotta install our serve packages, set the library as our serve, and start our serve using the command our serve. Install Tableau, open it, and then connect them together. Let's open our studio and install our serve. So in our studio, we can install our serve by typing install that packages, and inside the packages we can write our serve, press enter. Yes, I already installed the packages, that's why it says it's doing like a start new session. So wait a little minute. Yes, it's right here, so it's already installed. So once we install it, we can go to the library and serve. And once we clear the library, and after we clear the library, we can go with our serve and run it. So it says error because we should include no save this line, no save, and then this is optional found, I think. Let's start it again. Says add queues equal no save. Let's run this. Okay, and once we run this, it should go to the demos as you started in demo mode. So once we done this, it's right here, the demo mode, and then we can go to Tableau, open Tableau, and once we open Tableau, we can go to help and system setting and preference, manage and analytic dense, and then we have to connect the local host with this port. So I'm not going to use my username, and then once we test the connection, it says successfully it is connected to the analytic extension. Once we pick up, okay, that means these two are connected. So this is how we connect Tableau with R.
For the final part of this seminar, we'll be going over integrating Jupyter Notebooks with Tableau. A word disclaimer, the material that I'm working up here, I did not create it myself. Someone else made it. I'm just talking over and showing you how it works. There will be a link to the source material in the description section of this video. Anyways, let's take a look at this dashboard. It deals with breast cancer data. In the backend is a CSV file that contains various parameters related to cell samples taken from patients, as well as diagnoses on whether there's cancer cells or not. Suppose I want to implement a functionality where a user can input their own parameters into this dashboard, and the dashboard will return a predicted diagnosis of whether this constitutes as cancer or not. I could implement it using just bare Python integration and table calculations. However, that comes with some problems. Mainly that I will have to create and train my own predictive model every for every time someone makes a request. That is time and space intensive and might cause delays in returning the diagnosis if there are enough people inputting parameters at the same time. This can be resolved by training your model beforehand in a Jupyter Notebook and then connecting that Jupyter Notebook to a TabPy server so that when a user inputs their parameters, the the Tableau dashboard doesn't have to do all the extra work for no reason. Now, suppose that you want to do your model training beforehand in a Jupyter Notebook. To do that, you should create a Jupyter Notebook file, navigate to its location using a command console of your choice, and enter into it Jupyter Notebook, as it says over here, and press enter. Depending on how fast or slow your computer is, it might take a few moments, so just wait until you can see this homepage pop up. Once that's done, go to the file that you have created. Here we will take a look at an example of a Jupyter Notebook file that someone used to train their models beforehand. Here the author imports various libraries that they will use, does some introductory exploratory analysis into the data that they will be using in their Tableau dashboard, trains one of 3 different predictive models that they want, and selects one of them that they find to be the most accurate. The models that are used here doesn't really matter, mainly because you can choose to train as many or as few models as you want, and then choose as many or as few as you want. The important part comes here at the bottom. First, the author establishes a connection to the TabPy server on localhost 9004, which is the default port for TabPy. Then the author defines a function, suggest diagnosis, which takes in various parameters and then passes it into their predictive model and returns a diagnosis of malignant or benign. Lastly, and most importantly, the author deploys this connection established from earlier. The author takes the suggest diagnosis function, deploys it to the connection, and provides a little description. This is important because without this deploy part, your Tableau dashboard will not be able to properly connect to this Jupyter Notebook. Now that you have pre-trained your model on a Jupyter Notebook file and connected it to the TabPy server, the remaining steps are relatively easy. Here we will take a look at the calculated fields that you will need to implement this functionality. You might notice that this looks a little different compared to the standard Python integration calculation fields. We will go over what each part of this field does. We are expected to receive a string, malignant or benign. Here it asks to query the TAPI server given these arguments and to return a value response. And here it specifies the variables that will be inserted into the different arguments. The result, when this script is run, it will take off these parameters. It will pass them into the TAPI server, which will then pass them into the predictive model, which will then return a predicted diagnosis, which will then be passed back to the Tableau dashboard. To see this in action over here, as you can see, I have already inserted some values here, and currently the diagnosis is malignant. Let's change one of the numbers here from 10 to, say, 5. You might notice that the diagnosis went from malignant to benign almost instantly. This concludes our seminar on integrating various tools with Tableau. We will include our source materials as well as additional reading in the description of this video. If you have any questions, feel free to post a comment to the video or contact us in other ways.